and now we're ready to do the real thing. And maybe I could have the next slide. So the events of Rendezvous Day are largely the same as for Demo Day 2. We start off again 39 kilometers behind the station, and actually perhaps we could put the first video clip on here. So what we carry on straight into the station, stopping at the various hold points on the way to check that everything is right with the ATV and also with the station is ready to receive the ATV. These various hold points are particularly important because it's required that we make a go, no-go decision between the three flight directors at some of these points. And this requires a fairly fast reaction. The ATV then proceeds through the 250-meter point to the 20-meter point to the 10-meter point, and then proceeds right into to docking if everything is correct. Now, I mentioned that the crew is monitoring this last part of the operation. The crew is, if you like, our last line of defense, and they have the ability to wave off any rendezvous if things look as though they're going wrong. Perhaps I could have the next slide. Now, mounted on the front end cone of the ATV, we have a target, which is, let's say, which the crew looks at through a video camera, a CCD camera mounted on the top of the Zvezda aft end cone. And the crew looks to see that the approach of the ATV is within a predefined corridor. If it starts going outside the corridor, they have the ability to either execute an escape maneuver or even the collision avoidance maneuver, depending on where we are in the sequence. The crew won't do anything at all, of course, if the whole thing is nominal, and they will just watch it come in. So we get to a point about 1 meter away from the docking mechanism of the Zvezda, and at that point the crew will, at 1 meter away, we have what we call the crew hands-off point, and that's when it becomes, let's say, more dangerous to do an abort maneuver than to let the ATV actually come in. So it's important that the crew knows where that point is, and using a video screen in the Zvezda, which is known as the symbol, they overlay, we call it, well, it's actually a piece of perspex, which is called a rangefinder, range ruler, and there they measure the diameter of the target, and when it is a certain number of millimeters, then we know that we've reached the 1 meter point, and if it looks okay at that point, then the crew will let it come in. If it doesn't, then they will push the cam button. There's a big red button in the service module which allows them to quickly terminate a rendezvous if necessary. Okay, so now we are docked to the space station, and this is when the ATV mission in support of the ISS really starts. As John has mentioned, we are carrying a large amount of cargo, something like 1.2 tons of dry cargo, and this comprises a lot of supplies for the crew on board. We also have some spares. Actually, for Columbus, we're carrying up about 100 kilograms of spare parts, which let's say, the more critical ones, which could be used in the early days of Columbus. There are also various parts, stowage inserts for the Russian segment to provide a more effective means of storing stowage items in the Russian segment. We're carrying somewhere near about 900 kilograms of propellant to pump into the tanks in the Russian segment in order to replenish the reserves of fuel that we have on board. And during the stay of what is nominally 6 months at the space station, ATV will provide the capability to maneuver the ISS away from potential pieces of debris, and also to reboost the ISS orbit, and also provide propulsive attitude control in support of the other more passive forms of attitude control, namely the control moment gyros. For these functions, in order to perform these, the ATV propulsion system is actually slave to the computer in the service module, the Zvezda of the Russian segment, which through its software sends commands to the propulsion system thrusters on the ATV to perform the maneuvers. This is a very tight interface, and we've done a lot of testing to prove that works. Again, like the rendezvous itself, the refueling and reboost operations require close coordination between the control centers to make them work. And again, these have been the subject of several of our joint integrated simulations so far, and we have quite some confidence that we are going to be able to do this. The other things that we are delivering to the station are water and oxygen, and basically when we've delivered all that and exhausted our fuel, then we're ready to re-enter. And ATV is designed for safe re-entry, and after its mission, we command it to leave the ISS. And at a safe distance from the station, the ATV will execute a number of deorbit burns computed and uploaded by the ATV control center. The deorbiting sequence itself consists of transferring the ATV from a point in the orbit to a point on the Earth through basically a series of 2 maneuvers. The first one will put the spacecraft into an elliptical orbit. It's initially in a circular orbit, the same one as the space station. Puts it into an elliptical orbit and degrades the perigee, and then a final deorbit burn will reduce the perigee